So thank you everyone for joining this session. This is our third session on Google Cloud Camping. And today we'll be talking about networking, monitoring and operations. So I am again Rupak Vishwas from third year BTech and I am a Google Cloud Camp facilitator. So today we'll be looking about Google Network, Google Cloud Networking and Cloud Operations. So before jumping into this topic, so we should learn what is network or so what is this computer network anyway. So computer networking refers to connecting devices such as laptops, desktops, smartphones or any smart devices or some array of IoT devices that communicates with each others. So there are some special devices such like switches or routers or access points which helps us in this process. For communication process, it can be through paired twisted cable or like LAN cable or coaxial cables, or even it can be wireless communication through satellites, or it can be fiber optics also. There are different type of network like PAN, personal access network, or LAN, or, or WAN or MAN, etc. And there is some enterprise network also. For let's give me some example. So in our uh, like urban hostel, you guys may use some LAN connection. So these are one type of network. And in Kalam, we use both LAN. The routers are connected with LANs, and we use Wi-Fi network. So these are some hybrid network connection, and these are called enterprise network. So this is a pretty basic thing, and we use these things in a greater life. Then there are some other terms also like IP addresses, DHCP server, DNS servers are some important topics, but I'm not gonna going into this topics deeply because today's topic is some different thing. And about computer networking, we can define some categories also. So, there are SDN, or inter-based, virtualized, controller-based, multi-domain networks, etc. But let me discuss about SDN. By the way, this is the Google Cloud Network. I showed this picture in our session 1 also. So these things tells us about the zones and regions in Google Cloud. If you have used the Google Cloud console, then you might have came into these terms, the network zones or regions. So like this is US zone, then this is Asia zone. These are zones, and this is how these zones are connected through various things. So we will be discussing about VPC or VPC, and these are software-defined networks construction. So as SDN or software-defined construction is routing of in this way routing of traffic is controlled mainly through software-based mechanism. This are this helps us to quickly change the configuration. There are some other types I already mentioned, and this there is no IP ranges, and this term is global. We will be discussing these things in briefly in next slides. So this is an example of a virtual private configuration network, and these like there are 6 VMs running on. These 2 VMs is running on US East West 1A zone. These yellow boxes are zone, and the outer box are our region. So these 2 VMs are running in US West 1 zone, Then these two are running in US East 1A zone, and these are running in other zone. And these services are connected through this VPN with on other premises. And here is our VPC routing. So what it does, like, it connects through multiple zones, and it's give as a single public internet gateway. So what it does, like, it gives us the flexibility to configure the network what manner we like. And this is very convincing because you have freedom to configure in any manner. You can give access which VMs should access what thing, and which zone can be public for which purposes. So this is VPC routing. And there are another term, subnet. Subnets are like as the name suggests, subnets are like it is a network inside another network. Through subnetting, network traffic can travel a shorter distance without passing through unnecessary router to reach its destination. So subnet, like our IP, there is one important term, IP address. So IP address is like our home address or something, but for a computer device, so or network device, anything. So whenever we want to send some data or receive some data, so those data translate in terms of packets, and those packets need some address to where those packets should go, or where this packet should come. So there need to some address. So there is a thing, a server called DHCP server, which provides us IP address. And there are actually two types of IP address: static, public or private IP address. And these are some private IP address, and this internet gateway has some public IP address. And whenever we send some packets, this go through multiple nodes, multiple VPC routing services, and goes wherever it's need to be sent. So this is another configuration. Here we can see there is two zones: US East 1 and Asia East 1. And there is 4 virtual machine. This version and 5 virtual VPC network. In first VPC network is 2 VMs are connected through this VPC network, and this VM3 or VM4 have a public IP address. So these are internal services, and this communicates through these VPC networks. These have access to this VM1, and these have access to these things. So if we from VPC network, we can't directly access to this VM1, but from VM2 we can access to VM1. So this is some configuration examples. So this is all about which machine can access to which data, or which user can send request to which machine or something. So the subnet. So there are 2 subnet modes. One is auto subnet mode, and another is custom subnet mode. So this auto subnet mode is as the name suggests, this subnet is created automatically, and these have some predefined set of IP ranges, come with some default firewall rules, and expandable up to 16 only. And for custom subnet mode, you have to configure this. You have to configure these things, and these subnets and IP ranges are defined. No default firewall rules. You have to define your firewall rules or everything. And our VPC is made up of these subnets. As I mentioned earlier, subnets are subnetworks basically. So again, I am mentioning. So this is a network inside another network. Let's say we have an IP address let's understand these things with some real example. Like let's say I have a phone, and this as this have some SIM card or access provider. So this is uh, an access point of internet. So I can turn on hotspot, and I can give I can start my own DHCP server. If I connect my laptop with this smartphone device, so what it does, my phone have some DHCP server. It gives the laptop IP address, and I can connect multiple devices to this hotspot. So what it does, it gives some uh, IP address to all those connected device, and this creates a subnet. So all those connected device creates a subnet. The they can and this mobile is access point. Every connection, every request is sent through is the mobile. So if I search something in my Google tab, if I search something, so those searches will be transferred in terms of packets, and those packets will be flowing through my mobile phone device also. So this is how subnets works, and this is uh, uh, IP address, which consists of 30-bit, 32-bit integer or integer with 4 octet. This slash 16 determines the number of address bits that's static. So in this case, 16 bits are static, means this 16 bits are static. And for like if I have 5 devices connected, then 5 devices have some IP with 10.0.0.1, then 10.0.0.2, 3, 4, etc. So as I mentioned earlier, IP address can be of two types. One is public IP address or private IP address, or we can say internal IP or external IP. Those terms are symmetric. For external IP, this can be assigned from Google, or it can be static. Then in case of Google Cloud provider, if this external IP is not attached to some running services like VMware or something, then you have to pay some bill for that service. Then VM does not know the external IP; it's mapped to its internal IP address. So as I mentioned earlier, there are subnets and internal networks, and those VMs are directly not connected to those IP addresses. They are mainly connected through those their internal IP address, and those internal IP addresses are mapped through those their external IP address. This internal IP address are allocated from subnet range from VMs by DHCP server. So DHCP server are the main provider of those internal IP addresses, and they changed in every 24 hours. Uh, if you have ever come in Kalam, you can I think understand these things. So what happens? We have our testing Wi-Fi connection, and at every day 3 a.m. we have to re-log into those routers because our IP got changed, and those DHCP server needs to reassign those IP address. So we have to log in at 3 a.m. every day. Here we can say another term, DNS server. This DNS means domain name provider service. So what it means, like if you have ever buyed a domain, so what happens? Let's say I have a search engine. Let's say I have Google, and I search something like www.youtube.com. So how we got the result? So there is something called DNS server. So there are types of DNS server. So I don't, let's leave it. So there are DNS server. Whatever I search in the search bar, this query goes to the DNS server. The DNS server search for the URL and return the IP address of that service. Let's say IP address of youtube.com is something point something point something point something. So they return the IP address, and we send our packets to that IP address. So DNS server is mainly a query lookup for searching those IP addresses of a registered service. So these are some primary products included in Google networking. So virtual private cloud, load balancer, and cloud CDN, cloud interconnect, and cloud DNS server. So firewalls protect the virtual machine instance from unapproved connection. So you guys must have heard about firewalls. What is these things? So firewalls is our first line defense in our network security system. This is basically how you configure your system, which there are ports I mentioned earlier. So there are ports in our system. So this firewall rule says that I will hear on this port, let's say port 80. I will accept connection from those port 80, and I won't listen on another ports. So if somebody sends some packets on, let's say port 556, then it would be rejected. So this is how basically firewall works. You set some rules that there should be a post method with this with every request on this port, and it sets those rules for you. So firewall rules are applied to the network as a whole, and connections are allowed or denied at the instance level. So there are another term implied deny all ingress and LOL egress. So 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 how we can someone confirm is my screen freezed or not? I think my screen freezed. Hello, can someone confirm? Okay, then I am assuming that everything is okay. So we can express our desired firewall configuration as a set of firewall rules, as I mentioned earlier. Then we have to mention the direction of the rule. So it is incoming request or outgoing request. So this is basically we are sending packets or we are receiving packets. Then source or destination of the connection. We can mention which from which client or which IP address we will receive.
Bhaiya, could you please
We can set
unshare and then reshare the
I
screen?
will receive packets or I will receive packets from everywhere. And you can set some protocols and port of the connection. There are multiple communication protocols like SSH or HTTPS protocol. So you can
Bhaiya?
put some constraint on this protocol level also. You can set the action of the rule. Like for HTTP connection, there are GET requests or POST requests. There are other types of requests also. You can set those rules. Then there is a priority of the rule. So let's say you set post request priority comes before the get request. So if some simultaneous requests come, then they will get some priority, and you process those requests on your priority basis. So
Hello,
this is
Bhaiya?
some use cases of Google Cloud Firewall.
Hello, am I
Use
audible, Bhaiya?
Egress.
Bhaiya, could you please unshare and reshare your screen again?
Okay.
Yes, Bhaiya, visible.
Okay. So this is some sort of firewall use cases. So this firewall some external host and it have some firewall. Uh, it it have set some conditions like destinations, CIDR ranges, and some protocol supports. So it is taking some actions like permit the matching ingress connection or blocking the matching ingress connection. So you can do this kind of stuff. Then there is Cloud VPN for securely connecting on-premise network to a Google Cloud VPC network. So again, this VPN is not the VPN we use for our browsing purpose. This is service-to-service connected devices. Yes, this is site-to-site VPN, and this has some static routes. And you can use dynamic routers also for cloud router. You can configure IKEv1 and IKEv2 cipher. I don't know what it is, but these are some kind of uh, cipher algorithms, I guess. So this cloud interconnect offers two options to extend an on-premise network to a Google Cloud VPC network. This is cloud interconnect dedicated and interconnect partner. So whenever we subscribe for some services, we get some default network connection. That is Google Cloud Interconnect dedicated network. And if you are a service provider or yes, they already have a connection with Airtel or Jio or whatever uh, network service provider exists. So, but if you are a new service provider, let's say you have opened your own telecom company, then you can go for a cloud interconnect partnership also. So this is some comparison of interconnect options. So all these access types are internal IP addresses, and there are some requirements. You can look through this table. This dedicated interconnect and this dedicated and private connection to VPC, then it have capacity of 8 cross 10 GB circuits with pulmonary facility connections. So next we have our load balancing service to distribute user request among a set of instances. So why we need load balancing? So as the name suggests, this load balancing balance our traffic load. Let's say in the infrastructure as a service services, we need to configure these things, load balancing, or for other services like cloud functions or these things are handled automatically. So virtual machines things or this kind of uh, these sort of things we need to use this load balancing. So load this balance like HTTP's loads. You can set some HTTPS load balancing, which distribute the HTTPS or HTTP traffic among group of instance based on their proximity of the user, uh, based on the URL or both. So let's say you have a web application and you have hosted in both Europe and Asia region. There are multiple virtual machine on multiple zones running the same application simultaneously. So what it hap- what will it happens like if some Indian user going to request, then the Indian virtual machine going to will be prioritizing your request. And if they are loaded and the other one is empty, then they can serve also. So these are some kind of load balancing. You can configure them in Google Cloud Shell. Then not only HTTPS load balancing, there are some SSL proxy load balancing for SSL proxy load balancing, distributing SSL traffic among groups of instance based on proximity of the user. There is TCP proxy load balancing and networking load balancing. So these are external load balancing the load between some multiple instances or multiple services. And there is kind of internal load balancing also. This is like in a single device you can balance your load from, like, you can host your service in multiple ports, and you can uh, set up an internal load balancing service. So this is an example of using identity aware proxy. So these are we are done with the networking part, and these are Google's cloud operations suite. We have cloud monitoring, cloud logging, error reporting, cloud trace, cloud debugger, and cloud profiler. So we'll be looking into this one by one. So as the name suggests, cloud monitoring identifies trends, prevent issues, improve signal to noise, fix problems faster, and reduce monitor overhead. So whatever service you are going to run in their system, all those services will be monitored in real time. Of course, you can get into this configuration, which things you need to see or which you don't need. So you can turn off those services. It will monitor all those services like CPU uses or RAM uses or hard disk uses, or like if you have set up some storage services, then you might know, you might want to know, like, is my service is gonna filled up or not. So all those kind of all those kind of things are going to monitor in real time, and you don't need to enable those services. Those gonna enable automatically. You just you can directly access them. Then there is cloud logging. So logging is an important subject for even in web application to any service running service, because this is the first line of debugging step for if system got hacked or it have some problem. So you can define which uh, things it should log or should not log. So it seamlessly resolved issues, and all cloud logs you can find in one place. It is scalable and fully managed. It gives you real-time insights. And there is error reporting. Let's say you have some services running on your Google Cloud, and some of them have some issue on it. Maybe some VMs got hacked, or some language got system issues. So those issues are going to uh, get in error reporting services. They quickly understand your errors automatically. Uh, they give you instant error notification. These things are automatic and real time. It supports in most of the popular languages. And there is cloud trace for finding bottlenecks to system. Let's say you have a web application, full-fledged web application with a backend and front end, and you find that your application is lagging something or not giving the expected performance. So you might want to know, like, where it is lagging, or is it the database or the backend services or whatever the reason. So these things help you in these cases. Cloud trace, so it gives you real-time insight, the time response, where in which process it's taking how much amount of time. So you can look into this and fix your bugs or things faster. Then there is Cloud Debugger. This is kind of deprecated, and I think they are going to stop this service in 2023. So I'm skipping this. But debugging is an important step. So okay, in this. So next is Cloud Profiler, and this is low impact cloud profiling and for this bot platform support. This is for, I guess, multiple IAM user or uh, profiling purposes. So this is all about. Thank you for joining this session. I hope today I hope I would expect some questions from.